Hey Algebra 1 people, Mr. Hayward here. Today we are doing 7.8 practice. Okay? So factoring by grouping. Again, you will notice it's going to be short. On Monday, we only did 4 problems. I only made this one page because I don't think you need that much practice with it. But we'll do the even today. Short recap. Here's what we did. This is what it looks like when you have 4 different terms. You're not just looking at a trinomial. You're looking at a polynomial with 4 terms. Sometimes you can factor by grouping, where you look at the first 2 terms, pull out a GCF, and look at the last 2 terms and pull out a GCF. If what's left over is the same, then that means you can actually rip it into 2 different pieces. If it's not the same, that just means you can't factor by grouping. But since we're practicing factoring by grouping here, they're all going to work out. Alright, so we're going to shift over to number 2. So I am going to take it into 2 different pieces. I'm going to look at the first 2 terms, 21n cubed minus 9n squared, and I'm going to see if I can pull out a greatest common factor. Now, between 21 and 9, the GCF is actually 3. 21 is divisible by 3, 9 is divisible by 3. And then I can pull out 2 n's from both of them, because this one has 3 n's and this one has 2 n's. I can't pull out any more than 2 n's because this one only has 2 n's. Let's figure out what I'm left with. If I take these 2 terms and I divide by 3n squared, I'd be left with 7n minus 3. Okay? Then I look at the other 2. Now again, I'm hoping that I'm left with 7n minus 3. That's my goal. So I'm going to pull out a GCF here, and it looks like the GCF, I can't pull out any n's because this last term doesn't have any, but I can pull out a positive 7. And then I can take both of these terms, divide by 7. 49n divided by 7 is 7n. Negative 21 divided by 7 is negative 3. Fantastic. Now, that means that I can split this up into 2 different sets of parentheses. The first set comes from these things, 7n minus 3. The second set comes from what's left over, 3n squared plus 7. Now, it does not matter what order you write these in terms of if you write what's in red first or what's in blue first. It does not matter at all. But that is my final answer. If you ever want to double check yourself, you can take these 2 things, multiply them together, and see if you get back to where you started. Okay, so that's like if you're taking a test and you got extra time, why not? Or if you're really unsure if you got it right on a homework problem, you can give that a shot. All right, let's slide down to number 4. So same process. Whoop, there we go. So I'm going to start by looking at these 2. I'm going to completely ignore the last 2. Okay. 7x cubed and 21x squared. Well, between 7 and 21, their GCF is 7. And then 3x's and 2x's, I can pull out 2x's. Now let's see what I have left. If I divide this term by 7x squared, I'm actually just left with a single x. If I divide this term by 7x squared, I'm left with 3. So now I'm going to come here and I'm going to say I want to be left with x plus 3. But I have negative x minus 3. And I don't even have a GCF here at all. This is where you got to think critically. What could I pull out? What could I divide each of these by to make them positive? You could divide by a negative 1, meaning I could pull out a negative 1. Negative x divided by negative 1 gives me the positive x I'm looking for. Negative 3 divided by negative 1 gives me the positive 3 I'm looking for. X plus 3, that's my first set of parentheses. And then 7x squared minus 1 is my second set of parentheses. Or if you want to write them in the other order, 7x squared minus 1, and then x plus 3, same thing. And I'm done. It's factoring by grouping. Alright, slide down to number 6. You might instantly notice that our numbers are a little bit larger. Well, something that I hadn't mentioned yet, but you should always be looking for, is before you do any sort of factoring, you should see if there's a GCF you can pull out of the whole thing. It's kind of weird here because we're doing a lot of GCFs, but I'm going to look at all 4 of these terms and say, is there one thing that I can pull out of all 4? And in this case, there is. I can actually pull out 5 out of all of these. Now, if I pull a 5 outside, well, 45 divided by 5 is 9. Negative 120 divided by 5 is negative 24. 75 divided by 5 is 15. 200 divided by 5 is 40. And that should be a negative 40 because it is negative 200 divided by 5. Hey, those numbers seem a lot less sucky. Should we say it that way? Okay. Now, I'm going to ignore the 5, and I'm going to look at this in 2 different groups again. Okay? 9k cubed, negative 24k squared. I think between those, I can pull out a 3k squared. I'd be left with 3k minus 8. And then over here, again, I want to be left with 3k minus 8. So it looks like I can pull out a 5. 15k divided by 5 is 3k. Negative 40 divided by 5 is negative 8. Awesome. Do not forget that you still have this 5 all the way at the beginning. Now definitely don't forget that because that's part of your answer. I'm going to write it right now. I can split this stuff right here. Whoop, getting excited. Some great math we're doing. I can take this and I can split it up into 2 different pieces. 3k minus 8 came from these. And then the 3k squared plus 5, which came from these. But do not forget you originally pulled out a 5, a GCF of 5, meaning this is your final answer. If I said factor by grouping and you only wrote 3k minus 8 times 3k squared plus 5, you would be wrong. But we wrote it, so awesome. Boom, done. All right, we're going to try one more, and then we'll call it. So again, first thing you should always look for is a GCF. Do we even have a GCF here? Take a second, see if you can look at these 4 terms and figure out one GCF. I know right off the bat that I cannot pull out any letters, because my last term does not have any letters. But I actually can pull out 8 out of all 4 of these terms. If I pull out an 8, I would be left with 40x cubed plus 5x squared minus 8x minus 1. I get that by dividing all 4 of these terms by 8. All right, so now, right now, I know my final answer is going to look something like this. It's going to have an 8 in front, and then it's hopefully going to have these 2 sets of parentheses. Okay? So now I'm going to split this up here, here. All right, so let's ignore the 8 and let's ignore the last 2 terms, and we're just looking here. What can I pull out of just those 2 terms? Looks like I can pull out a 5 and 2 x's. And then I'm left with 8x plus 1, right? Because if I take 40x cubed divided by 5x squared, I get 8x. And 5x squared divided by 5x squared, I get 1. All right, now I'm going to look at these 2. Now my goal is to be left with 8x plus 1. Well, again, you see I've got a negative 8x and a negative 1. What did we just do when we ran into that situation? We pulled out a negative 1. Negative 8x divided by negative 1 is negative 8. Oh, forgot my last parenthesis there. And then negative 1 divided by negative 1 is a positive 1. So 8x plus 1, that's what was left inside the parentheses. And then everything left over, 5x squared minus 1, my other set of parentheses. And this is my final answer, and I'm done. All right, so short recap, factoring by grouping. You can only do this when you have 4 terms. Okay? We're not going to talk about factoring with 5 terms other than just pulling out a GCF. We're not going to get that crazy, especially not this year with quarantine and whatnot. But factoring with 4 terms, you can first look to see if you can pull out a GCF out of everything. Then you split it up into 2 pieces, pull out GCFs. What's left inside the parentheses, that's 1 set, and then everything else is another set. And you can see I ripped it into 2 binomials. That's it. All right. Hope that went well. Miss y'all. Hope to see you soon.